Okay, so I know your page looks slightly different from this, but it has the same questions on it. It says, what do we call an ionic compound that has two elements? We're going to call that a binary ionic compound. And I'm going to put compound. All right? Binary ionic compound. And then what do we call an ionic compound with more than two elements? We're going to call that polyatomic ionic compound. Okay, binary polyatomic. And you're going to hear a lot about polyatomic compounds. All right, you should have already answered those questions. Okay, so when we're writing chemical formulas, we're learning how to write chemical formulas. We're going to use oxidation numbers. And where are we going to get these oxidation numbers? That's why we have an ion chart. See all these numbers on here? Those are our oxidation numbers, okay? All right, so we're going to need those because all our ionic compounds need to equal 0 when we're finished writing those. And that's a key concept right there. When we write an ionic compound, it needs to equal 0. All right, so I'm going to teach you how to do these. All right, here's the steps. I know yours is numbered slightly different from mine, but it's the same information. Okay, we're going to use what I call the swap and drop method for writing compounds. Okay, so step one, we're going to write the symbols of our elements. So we're going to find barium and chlorine on our ion chart. So here's barium. Barium is a +2. And then I find chlorine, because remember this is metals plus nonmetals. There's chlorine that becomes chloride when it's an ion. That's why you see these IDE endings on these nonmetals. But chlorine becomes chloride, and it is a -1. A little negative symbol means -1. If you see a little plus sign like these over here, that's a +1. Okay, so I'm going to write that here. I've got barium, who's a +2, and chlorine, who is a -1. All right, so when these form ions, this loses 2 electrons, this gains an electron in bonding. That's what that's telling you. But what are we going to do with these to write our formula? We're going to do what we call swap the numbers. So I'm going to swap this 2 down below the chlorine, and I'm going to swap this 1 down below the barium. So remember before I said these numbers are called subscripts. This is in our notes from earlier. When you see a number under here, under means sub, it becomes a subscript. So it says my formula has how many barium? 1 barium. How many chlorine? 2 chlorine. Okay? I don't express ones in a formula. Just having that element symbol there says there's 1 atom of barium and 2 atoms of chlorine. That is your formula for barium and chlorine, which becomes barium chloride. Okay, now where does this 0 come in? All right, so let's think about this for a minute. If I have a +2 barium and a -1 chlorine, that's a 1, sorry, that's a 1, and I look at that, that doesn't equal 0. So what do I need? I need 2 of these -1 chlorines to cancel out this +2. So that's why I need 2 chlorines for every 1 barium. So that's why it's BaCl2. But rather than doing math, because I know you don't want to do math, we're just going to swap the numbers, drop the signs. Okay, what happens if we have elements like sodium and bromine, where sodium is a +1, bromine is a -1. So right here, what happens if I have a +1 and a -1? All right, those cancel out because that already equals 0, right? So these just cancel each other out. So it is a 1-to-1 ratio of sodium to bromine. Okay, so I want to see if you can do these. So try these right here. Turn off the video. See if you can try these. If you want me to come check them for you, I will. And then we will start the video right here doing these ionic compounds with transition metals. So stop the video, practice, And I'm going to move on here, though, to these. Okay, so when we have ionic compounds containing transition metals, and where are those transition metals? You should know this from your periodic table. Here's our transition metals, or some of these other metals also have more than one oxidation number. You see that? So let's take, for example, iron. There's the +3 iron, the +2 iron. There's the +2 copper, +2 nickel, the +3 nickel, +2 copper, +1 copper. How do I know which one? Well, it's telling me these Roman numerals right here correspond to the oxidation number. Notice that? Okay, so we're going to use those to write formulas. So right here it says I'm going to use mercury 1 and oxygen. All right, well, mercury is number 80. Notice we have two choices here. We've got the +2 or the +1, and it says we're going to use the +1 oxygen, or +1, mercury. So again, mercury, the +1, oxygen is always -2. Notice none of our nonmetals have more than one oxidation number, so it's always -2. So when I swap the numbers, drop the signs, I get 2 mercury and 1 oxygen. All right. Let's do another one. What if I have mercury 2? So this time it's telling me which mercury am I using, the +2. How do I know? Well, if I look on here, that Roman numeral 2 tells me to use the +2. Okay? And then oxygen we know is always -2. What happens if you have a +2 and a -2? They cancel each other out. So I get HgO. All right, let's see if you can complete C, D, and E on your own. Stop the video. See if you can complete those. And I can check them for you if you want me to. I'm going to continue on to our polyatomic ions. All right, when we've got compounds containing polyatomic ions, they're called polyatomic compounds. Okay? It's still, we're going to have metal ions or positive ions with these negative polyatomic ions. Notice down here there are 2 positive polyatomic ions, but the rest of these are all negative ions. Okay? Our clue that we're using polyatomic ions is they end in ATE or ITE. There are some exceptions that end in IDE, but for the most part they end in ATE and ITE. Clue that we're using polyatomic ions. Okay, so let's look at one. We've got magnesium. Just plain old magnesium. He's a +2 right here on our ion chart. So I'm going to have magnesium +2. Okay, and he's with nitrite. So that ITE ending tells me, hey, you need to look up here at your polyatomic ions. They're in alphabetical order. So nitrite is right here. This whole entire thing, this NO2, has a -1 charge. So when you write nitrite out, NO2, put it in parentheses so you know that's a little family and you can't break it apart. We're going to put it in parentheses and we're going to put a -1 out there. So this is a family, the nitrite family. Do not break it apart. Keep it together. Because when I swap and drop with this, I'm going to take this 2 and I'm going to drop it back behind this nitrate. And the 1 goes back behind the magnesium. So this is important. I have 1 magnesium and how many of these nitrites? 2. You have to have the parentheses, otherwise it would look like 22 oxygen. So I need parentheses. Again, make sure it's outside. Do not change anything inside the parentheses. All right? Let's look at C. I've got ammonium. And let's recall again, ammonium is one of the only positive polyatomic ions. Okay, I've got hydronium and ammonium. So ammonium, it's kind of big. I'm going to write it here. I'm going to write NH4. And again, I put that whole thing in parentheses with the +1 outside. Because that whole entire thing has a +1. That's not +4. It's +1. All right, so I've got that plus nitride. Oh no, I'm looking at the wrong one. Chlorate. ATE, there's my clue that I've got an ATE. Chlorate. So this is also another polyatomic ion. So we've got two polyatomic ions together. And again, that's ClO3 in parentheses with the -1 outside the parentheses. -1. So what happens when you have a +1 and a -1? They cancel each other out. So then I just rewrite this whole entire thing, NH4 ClO3, ammonium chlorate. Okay, so again, here's a sulfate, a dichromate. Those are your clues you're going to look up here. Nitride, though, that ITE, if I go to the ends, there's nitrate, nitrite. Where do I find nitride? Right here, because that IDE ending, that's your clue. You're over here in these nonmetals. I want to see if you can do A, D, and E on your own. Let me know if you need my help.